Hello, today we're looking at surface area, but this time we're going to focus on composite voids. Now the goal for today is to find the surface area of these three shapes that you see. Now each of these three shapes have a hole in them somewhere. We call this hole a void. So if you want to learn how to find the surface area of these three, stick around. So sometimes you'll be asked to find the surface area of 3D shapes that have a section missing. We call this missing section a void. To find the total surface area of a shape with a void, we're going to do three things. We're going to find the surface area of the main 3D shape. Whatever the object is, we'll just find the surface area of that. Then we'll subtract any voids or holes that we can see. And finally, we'll add any extra internal sides that have appeared because of the void. Okay, so for example, a wooden storage shelf is shaped like a rectangular prism. What is the surface area of the shelf? So we have pretty much a rectangular prism here, but the front and the back have a hole in the front. So they have a void at the front and a void at the back. And this makes this box now a shelf. So how do we find the surface area of this? Well, what we're going to do is we're going to follow three steps. We're going to pretend that there was no hole at all. We're just going to find the total rectangular prism. Then we're going to take away any voids that we see. And then we're going to add on the inside rectangles that we can see now. Okay, so for the first shape, if this was a box and there was no holes in it at all, it would just be a rectangular prism. So if we use the rectangular prism formula and the numbers that we've got, we'd get 1600 centimeters squared. Now we can see on the front here that there's a square missing. We can see that it's 18 centimeters by 18 centimeters. So there is a square missing at the front. So this is a void. So we're going to work out the area of that void. So 18 times 18 is 324. And now, because there is a void at the front of the box and also the back, we're going to times that by 2. So we end up with 648 centimeters squared. So there's 648 centimeters squared we're going to have to take away because it's no longer a part of our box. Now, if you look closely, because we've cut holes in the front and the back, there's now inside surface area. There's a rectangle at the bottom and the top, and there's a rectangle on the right here and the left. So we also need to add those on. So for the inside rectangles, it's going to be 18 centimeters by 10 centimeters. So this one here is going to be 18 centimeters high times 10 centimeters this way, and there's two of them. And also the bottom is going to be 18 centimeters by 10 centimeters as well. So that added to 720 centimeters squared. So overall, to find the total surface area of this box, we're going to take the original 1600, take away 648, and then add 720. And this will give us 1,672 centimeters squared. All right, let's try another question. A metal dice has a hemispherical portion removed. The hemisphere touches all edges of the top of the cube. What is the surface area of the remaining metal? So basically in this situation here, we have a cube that's had a circle taken away from the top, but also now a hemisphere has appeared at the top. So even though we've taken some portion out of this cube, more surface area has popped up for us to work out. So to find the cube, it's really straightforward. It's 1 times 1 times 6 sides, so that's 6 centimeters squared. The circle at the top that's missing is just going to be pi times 0.5 centimeters squared, because the radius of that circle would be 0.5, so we get that answer there. And to find the inside hemisphere at the top, this little dip here, we're just going to have to do half a sphere. So it's going to be 4 times pi times 0.5 squared, but we divide by 2. Now that we've got our three areas, we can go, the original cube was 6, we're taking away the 0.7854 for the circle, and then we're going to add on 1.5708, and we get 6.79 centimeters squared. So this is one of those weird questions where we started with a surface area that was 6 centimeters squared, and we ended up with a bigger surface area. So even though we took a bit away from the cube, we took some of the volume away, our surface area increased, which is kind of interesting. Okay, for our last example, you can read the question for yourself, but I'm just going to explain the diagram. So we have a metal pipe, okay? This metal pipe, let's just pretend it's used for water, okay? So we can see that it has an internal radius of 10 centimeters, so that's how wide this circle is, but the whole pipe has a radius of 20 centimeters. And it extends 2 meters this way. So the question is asking you to find the surface area of the whole thing. So it's the whole outside, all the inside, as well as these circular ends here. Now, the easiest way to do this without making mistakes, first of all, is to just find the whole entire cylinder. Pretend there's no holes, so just find the whole cylinder, Then we take away the circles on the end. So we're going to take away the circle here and the circle here. And then we're going to add on the inside rectangle. So just remember this curved area here that goes all the way through will unfold into a rectangle. So we just need to add that on at the end. So let's find the large cylinder. So we're just going to use the surface area formula for a cylinder. So I'm going to use 0.2. Now just remember, these units are not the same. Centimeter, centimeter, meters. Now because the question said in meters squared, I want everything to be meters. So instead of 20 centimeters, I'm going to use 0.2. So 2 times pi times 0.2 times 0.2 plus 2 is 2.7646 meters squared. So that's the whole entire cylinder if there was no holes at all. The next thing we need to do is work out the circle void. So we know the radius of this internal shape here is 10 centimeters, so I'm going to use 0.1. So pi times 0.1 squared gives me that answer there, and then I double it because we're losing a circle on the front and the back of the pipe. So we're going to take away 0.0628 meters squared. And finally, the inside rectangle, well, this is pretty much a cylinder without the circles, so we're just going to use the rectangle part of the original formula. So 2 times pi times 0.1 times 2, and that will give us 1.2566 meters squared. So all we have to do now is find the whole entire large cylinder, take away the circles on the end, and then add the inside rectangle, and we'll get 3.96 meters squared. Thank you so much for watching. Hopefully that makes sense. So if you're ever asked to find the surface area of a 3D shape that has a void in it, I suggest you find the whole entire shape, and then you take away any voids you can see, and then add any insides after. Hope you guys have an awesome day. See you next time.